Hello everyone, I welcome you all in this video. From this video, we are starting the new chapter that is advanced casting processes. And before going to start about, means before going to discuss about detail of these advanced casting processes, I just want to brief you about the casting terminology, or we can say that what are the casting elements that are required. Generally, these elements you have studied in the when you have studied simple casting processes. So, but is now we have to use, because there will be like terminologies that again we have to use. So just to remind us, I just want to brief you about these terminology. Okay, so in this video we are going to discuss about the definition of this casting. Okay, and the terminologies, or we can say that what the elements that is required for the casting that we are going to discuss in this video. Okay. Okay, so first, okay, so first of all, the definition of this casting. So, as per the casting definition, casting means whatever the pouring of the molten material. Pouring of the molten material. Molten material means the liquid metal. Okay, that molten material we have to pour into the mold cavity. Now, the mold cavity is means what the shape that we have to require or we have to form. Okay, so that shape of the cast mold cavity we have to form first. Then we have to pour this molten material into this mold cavity. Okay, and we have to keep it up to some when it reach to the solidification temperature, or once it completely solidify in this mold cavity. After that, we can bring it out, or we can taken out of this mold cavity. Either there are two things. First, if this mold, generally we are make this mold by the sand. So if we are making this mold with the sand, so we can break this mold, or if it is made up of some other material, then simply we can shake it in this direction. Okay, we can shake it and we can remove the material. So whatever the material means whatever the solidified that has been removed from this mold cavity, we call this as a casting. Okay, so this is a simple definition of it, and that solidified object is called as a casting. Okay. Okay, let's move forward. Yeah, in this video, sorry, in this uh, in this slide, here we are going to discuss about the casting terminology. So before going to detail, before going in detail about this, that how it works, first of all I want to brief you about what are these elements basically. So first of all, we are using this outer box. Okay, so in outer box, if middle line, we call this middle line as a parting line, and we are using this parting line because we have to differentiate two parts. Okay, so the top part, we call this top part as a cork, and the bottom part we call this as a drake. Okay, sometimes sometimes we use three parts, so because that third part is basically in between of this top and bottom, so this third part is call it as a cheek. Okay, so if in case somebody asks that three parts, what is the third part, that is a cheek. Okay, so next is, yeah, first of all, uh, here we are using the ladle basically, in which the material, molten material or the liquid material is filled. This material is poured into this pouring basin. Okay, this is a pouring basin. After this, now this shape of this pouring basin sometimes can be like this as well. Okay, and sometimes it's like this. It depends. Okay, but that which material we have to, which liquid material we are using, okay, on the basis of that viscosity. After that, we are using this sprue. Generally the shape of this sprue is taper section. Here I have made this vertical line, but try to consider it as a taper section. Okay. Next to this sprue, the material is entered into this runner. So runner is basically a horizontal passage. Okay. So this material is entered into this side, and it will fill in this runner. Okay. Next to the runner, there is a gate. So the gate is basically, after the gate, whatever the molten material that passes through that gate, it's directly enter into the mold cavity. Okay. So now here, this is a mold cavity that we are using. Okay. So this is a mold. Sorry. This is a mold cavity that we are using. Now, just assume that when you look from the top side, the cross section of it, either it's a circular cross section, or it can be a square, or it can be a trapezoidal. Okay, it means that whatever the molten material that enters from this side, it will completely fill this mold cavity up to this height. Okay, so if you will, means once the material is solidified, and if you look that, it will looks like, if we are considering this cylindrical section, then it will be a rod, okay, of circular cross section, or it can be a road of square cross section, it can be a road of trapezoidal cross section. So whatever the road, we call this road as a ingots. Okay. Now after this mold cavity, once the molten material is up to this height, after this enter into this vertical portion, we call this vertical portion as a riser. So whatever the molten material, which is, we can say that excessive molten material that come out from this riser, and once the material, molten material coming out from this riser, we stop this uh, molten material which is we were pouring from this ladle. So we stop this because this material, now this mold cavity is filled. Okay, here we are using also the gas vent. So if there are like some air or the gas is entered along with the molten material, so that gases is removed through this gas vent. Okay, otherwise if there will be an entrapment of the gases, that will make the porosity. Okay, so because of that, the strength of the material or the casting is reduced. So for that, we are using this gas vent. Now, these are the elements. Now I'm going to discuss about in detail. Okay, so once the molten material through the ladle is poured in this pouring basin, as I said that sometimes we are using the size of this means shape of this mold pouring basin like this. So once the molten material is start filling in it, it will reach to this height. Okay, when it will reach to this height, as we are continuously pouring in it, so it will start moving in this direction. Okay, so we can also say that for the smooth flow, we are using this shape of this pouring basin. Okay, now when it will come out from the pouring basin in a smooth flow, it will enter into this sprue. Okay, now as I said that sprue is not vertically cylinder, horizontal cylinder, sorry, a hollow cylinder. It's basically a taper section. Okay, so if you will look at the cross sectional area at the beginning, it will be like this, and at the end it is somehow less. Okay, so because it's a taper section. Why we are using taper section? Because like whatever the molten material which is coming through this, okay, it is through this pouring basin, it is not complete, this area is not completely covered by this molten material. Uh, a little bit area is still left. Okay, so because of that, what happen if we'll use completely a cylindrical portion, okay, a hollow cylinder if we'll use, then throughout whatever the area is left in the beginning, like this area is still remaining, okay, this size. So this area will left throughout this length of this sprue. Okay, so because of that, once is the molten material is moving inside, the gas will also start moving inside of this along with this molten material. Okay, so that will basically form excessive amount of the gases, means because of that the excessive amount of the gases reach inside this runner or this mold cavity, so that will not be helpful for it. And another is because of this gas entrapment, again as I said that there is a form of the porosity. So to avoid or to prevent this gas aspiration effect, to avoid or to prevent this gas aspiration effect, we are using this shape of this sprue is taper section, is in taper section. Okay, so this is up to this sprue. Now once the it will reach to this, it's start filling in this cylindrical as this spherical portion. When it will reach fill up to this height, start moving inside this runner. So runner is basically a horizontal passage. This molten material start filling up to it, and filling this is after the runner we are using the gate. So if you will compare this area of this gate, then the area of means if you will compare this area of this gate of the bottom part of this sprue, means area of this bottom part of this sprue, then area of this gate is less. Now it depends that there are two types of different types of gates. On the basis of that, means it's whether it's a pressurized gate or unpressurized gate. Okay, so on the basis what the area ratio we are using, okay, throughout, so means accordingly we can use. But if you will look at this surface, sorry, this area, then this area is lesser than this area, means the more amount of the material, because whatever the molten material is entered through the ladle, the flow is same. Okay, if the flow is same, then the if the here the area is high, then the whatever the molten material is coming inside, because it we have the space as well along with in this runner or in the sprue or the pouring basin. So this molten material is basically filled inside this runner, is it will enter inside this gate, and it will come out into the mold cavity through this gate. The velocity of this increases because the area is here, the area is reduced, therefore the velocity is increases, because as I said, the flow rate is constant and the flow rate is given as the area into velocity. Now if you are reducing the area, it means the velocity is increases. So if we are using this less area, then it means the velocity is increases. Okay, so the molten material which is entered inside this mold cavity through this gate, it has quite good velocity comparatively what the velocity of this molten material over here, here and here. Okay, and we need this velocity because we are filling above this height. Okay, so once the molten material enter into the mold cavity through this gate, first it will fill this space. Okay, once the space is filled, it will reach to this height which is equivalent to this gate. Now if this speed will not be high, then this pressure head or this head is not covered, or what the height is remaining, it is not covered by this molten material. So for that also we need the pressurized gate. Now if it has a good velocity, then it will start filling this molten material up to this height. Okay, now after this height, whatever the molten material, if this is completely filled, or whatever the gases particles or air particles are there, that is removed through this gas vent. Okay, now this gas vent is also means it can, now I have mentioned it over here, this mold cavity along with that. Sometimes in some of the books it's mentioned over here. Okay, along with the runner. In some of the books it's mentioned over here along with the gate. Okay, so it's basically a small size, small cross-sectional area. It's a kind of tube. So just to uh, just to avoid the gas entrapment, so that's why we are using it. So once the molten material is completely, this mold cavity is completely filled up to this height, the molten material which is in the liquid form is start coming out from this region. Okay, now is the molten material which is like when the molten material which is reached up to here, and the molten material liquid material which is coming from this side, this will like is while filling also it takes a time because it do not have that much viscosity comparatively with the water or the other liquid elements, because it's a liquid in form, but it's a material, metal, okay, metal or non-metal, alloy, whether it's alloy. So it has some less velocity, so it required it needed some time to fill up to this specific height. So if this material is completely filled up to this height, specific height, then whatever the amount or the thickness of the molten material which is over here is the fresh liquid which is coming over from this gate at this position. So now this material starts solidifying. Okay, so when it will reach up to this, and when it will come out to from the riser, whatever the material which is coming out from this riser, either it will be in solidify form, or plus it will be a liquid. If it is not a liquid, then it cannot move outside. But please keep in mind, whatever the material that is come out, that is in the form of solidification, solidify form or liquid form. Okay, so that material come out through the riser. Okay, so this is a working of this this is the working of this uh, means how to fill the casting element. Okay, next is the about these elements. So first, the pouring basin is, as I said, it's a small funnel shaped cavity at the top of the at the beginning, or the top of the mold, which allows the molten material uh, for a smooth flow. Okay, in which the molten material is entered. Okay, next is the sprue. It's basically a passage that allows the molten material, and which basically transfer the molten material from the pouring basin to the mold cavity or to the runner. Okay. Next is the runner. It's a channel, horizontal channel we can say, which allows the molten material, which is to flow from the sprue to the gate area. Next is gate, as the said, that gate which allows the molten material into the mold cavity. Okay. Riser, which is it's basically a column of the molten metal that's placed on the mold, okay, to feed the casting as it shrinks and solidify. Okay, next is a gas vent, just to facilitate the escape of the air and the gases. Next is another the same figure, similar figure like, but here in this we are making a hollow casting. Okay, so if we want to make a hollow casting, like this is a casting, this is the mold cavity. Okay, and like we can just assume that it's a circular cross section. Okay, and in circular like cylinder we are making, but the cylinder is somehow uh, in between there is a some this small cylinder is hollow portion. Okay, so what we have to do is we have to insert a core. Okay, there are two methods. So first is like up to this we can fill this molten material, this mold cavity, and once this material is solidified, after that we can keep this core over it, and then we start filling the molten material again. But now as this material is completely solidified, and which will restrict, because this has been filled up to here, that will restrict the motion of this liquid material inside this mold cavity, so that molten material cannot be entered into the mold cavity. So that cannot be possible. Now the only way is left is we have to hang this core inside this mold cavity. Okay, so simply we cannot hang with any string. Okay, because the temperature of this liquid material is very high. So when this molten material is, and means when this molten material is entered, the string will cut out, so it core can be placed at any place randomly. So we have to means keep we have to keep in mind the size and the shape of this mold cavity, and accordingly we are placing the core. First of all, this core is generally made up of the sand or the casting sands. Okay, this is completely a sand. This core is completely made by the sand, and now we have to hang it in between the mold cavity. So what we are using the chaplets. Okay, now once through this chaplets we have hold along with this mold cavity, means boundary of this mold cavity or this core, we have placed the chaplets in between that and hang this core. Okay, now we are filling this molten material inside the mold cavity, and it start filling over it, and this will reach up to again here, and this move out, and we stop this entering of the liquid material. So what will happen that once the material is solidified, now this when this material is completely solidified, what we have to do is either we just have to make a little hole through this drill machine, or any micro finishing processes. So what we have to do once this drill hole is formed, what we have to do, we have to just dig it. Okay, we have to just dig it inside by the small amount of the force, as this is a sand, so it will break. This particles are breaks, and by removing, we can also remove this sand from this side, okay, through which this drill portion. Okay, now this is about the core, so that whatever the sand particles are there, that can be removed through this area. And after the once the sand is removed from the side, we can easily weld this portion. So welding for the casting, that no, because it's a small area, so that can be easily can be done. Okay, but what about these chaplets? This cannot be removed. Okay, so what we have to do is, if we are making this casting of the aluminum material, okay, or a specific series of this aluminum material, then the same series or the same material we have to use for the chaplets, because it will become a part of this casting. It cannot be removed from this casting. Okay, so it will become part of the casting. Okay, that cannot be removed. So please keep in mind, the chaplets are the that cannot be removed from the casting. It will become a part of the casting. And when we are using these chaplets, when we have to form a hollow section. Okay, so this is about this hollow part. Next is yeah, this core is, as I said, to whenever we have to make a hollow cavities, that time we have to use this core, or it basically is it will separate the hollow part and the solid part. Okay, chaplets are generally used to support the core inside the mold cavities. It also handle the its own weight, means chaplets weight plus the core weight, as well as it will overcome the metallostatic pressure forces. Okay, next is the same figure, like what we have discussed about this hollow casting I'm using, because in the last both the figure I have mentioned this. This is like a simple figure which you can easily get in any book, any of the books. Okay, now here I am using a conical shape. Okay, means this type of shape I have used. Uh, this type of shape I have used in the previous two figures. So now I am little bit just changing so that you can get a clear idea. Okay, so now in this video, means in this figure, I'm using a conical shape. Okay, this is circular, and this is also circular. Means what I have, this basically this is the final product we needed. Okay, now what we have to do, if this is this is basically the portion where the material is filled, and this is basically a blank portion. Means this is the hollow cavity. So what we have to do is, we have to make this portion of the core. Okay, means from the sand we have to prepare this core portion, like this we have to we have done over here, and we are using the chaplets to hang this core. Okay, so the material is entered through this gate and start filling this mold cavity. Okay, so this portion is this is a solid part, so it will not fill, but rest of the boundary is completely filled of this mold cavity by this molten material. Okay, then it is come out once this mold cavity is filled. Okay, then we stop this liquid material entering, which is entering. Okay, so this is a simple figure. This is about the casting terminology from my side. These are the references that I have taken for this video, and thank you so much, guys.